Ever wondered how gases behave when they come in contact with solid surfaces? Well, let's dive into it. Picture this: a gas or liquid solute encountering a solid or liquid surface. Then, instead of bouncing off, it starts to accumulate, forming a thin film of molecules or atoms. This isn't some fancy science fiction scenario, it's a natural process happening all around us. This phenomenon, my friends, is what we call adsorption. Now, how can we quantify this behavior? To quantify this behavior, we use something called the adsorption isotherm. Now, you might be wondering what exactly an adsorption isotherm is, right? Well, it's a graph that illustrates how the quantity of an adsorbate, which is the substance being adsorbed, varies with its pressure or concentration at a fixed temperature. Picture a curve that rises, plateaus, then levels off. That's your adsorption isotherm. But it's not just one size fits all. There are different types of isotherms, each with their unique characteristics. Let's touch upon two of the most common ones, the Freundlich and Langmuir isotherms. The Freundlich isotherm, named after the German scientist Herbert Freundlich, is an empirical relation used for non-ideal adsorption, where the concentration of adsorbate on the adsorbent surface is not uniform. It's a bit like a party where people cluster in different spots rather than evenly spreading out. The Langmuir isotherm, on the other hand, conceived by Irving Langmuir, assumes a uniform energy of adsorption onto the surface and no transmigration of adsorbate in the plane of the surface. Think of it like a well-organized grid where everyone has their designated spot. So, an adsorption isotherm helps us understand and predict how different gases will behave on different surfaces at a given temperature. Interesting, isn't it? Let's quickly recap what we've learned today. We started by defining adsorption as the process where gas or liquid molecules accumulate on the surface of a solid or a liquid. We then dove deeper into the concept of the adsorption isotherm, which is essentially a curve that shows the amount of gas adsorbed by a solid at constant temperature as a function of pressure. We learned that this model is critical in various fields, including environmental science, where it helps us understand how pollutants stick to surfaces, and in industrial applications, like in the design of catalysts. It's a fascinating mix of chemistry and physics that gives us insight into how molecules interact with surfaces. Remember, the world of science is full of such intriguing concepts waiting to be explored, and that, folks, is a simple way to understand how gases interact with solid surfaces and how we can predict this interaction. Keep exploring, keep learning,